All right, the next example that I'm going to work out asks you to calculate the energy required to melt 40 grams of lead. All right, so notice here they're not asking us to calculate any temperature changes. It's simply a change in phase. How do I know that? Because it's telling me by this word melt right here. It's not asking us to change any temperatures, it's just asking us to change phase. So what I would need to do is I would need to go ahead and get my formula set up. I'm looking for a change in energy, and in this case melting is a phase change from a solid to a liquid, and so that's going to be the latent heat of fusion. So to calculate that energy, my delta Q is going to equal to the mass times that heat of fusion. And in this case, we're working with lead, so we need the heat of fusion of lead. One of the other things that I'm going to do right off the bat is I'm going to go ahead and convert that 40 grams. We never want anything in grams, we want it in kilograms. And so the mass is going to equal to 0.04 kilograms. And that mass is going to be used right here. So delta Q is equal to 0.04 as our mass, and now we need the latent heat of fusion for lead. This is where that chart I gave you comes into play. First thing you're going to want to do, kind of familiarize yourself with it. Okay, these are the freezing points, these are the heat of fusion, the specific heats, the boiling point, and the heat of vaporization. On the left side over here, you're going to notice I've got a bunch of elements and compounds listed. All right, so what we're going to want to do, the heat of fusion is the second column. And so what we're going to want to do is look for lead. Here it is. And we're going to want to move over to the second column, and that's my heat of fusion for lead. What I would do if I were you, just to be safe, I would go ahead and label LF, C for specific heat, LV on this side, that's your heat of vaporization. This is the freezing point, so I'm going to call this FP. This is the boiling point, so I'm going to call this BP. Just to kind of remind myself of where everything is on this chart. All right, back to our problem. We're looking for lead, and we need the heat of fusion. So I'm just going to do just like you did in social studies. It's kind of like a chart. That is the latent heat of fusion for lead. So I'm going to plug that in to my equation, 2.47 e to the 4. Now all you would need to do then is take your calculator, multiply the two numbers out, and your change in heat will be measured in joules. And that's it.